To make humanoid robots truly useful in the real world, they can't cost hundreds of thousands of dollars. The goal is to get them down to the price of a decent used car. If Tesla can bring Optimus down to the $10,000 to $20,000 range, that changes everything. Long term, you might be able to pick one up for around $20,000 to $30,000. That's not a fantasy, it's where the tech is heading. The real breakthrough isn't just that a bipedal robot can lift a box or pour a cup of coffee. Boston Dynamics has been showing off flashy demos for years. What makes Tesla's approach different is the price. When something is cheap enough to be everywhere, it stops being a party trick and becomes a serious tool. A $20,000 robot could be an appliance, not a showpiece. And that has the potential to reshape the economy. The question is, will these affordable bots actually transform industries, or just become expensive toys for the elite? Welcome to Auto Intel. Today, we're diving into why Tesla Bot Gen 3 might be the most important step forward in AI robotics yet, and how it might actually hit that low price point. To pull this off, Tesla is leaning hard on its manufacturing muscle, the same infrastructure already powering Model Y production in Fremont, Shanghai, Berlin, Austin, and now Mexico. From actuators to control boards, sensors, and especially the 4,680 battery cells, every component in Optimus travels along Tesla's existing supply chain superhighway. That means even small savings, say, a cheaper weld or a more efficient casting, ripple through and bring down the overall cost of the robot. Optimus isn't a moonshot built from scratch. It's a derivative of Tesla's existing empire. Inside Gen 3's frame is a 3 kWh 4,680 battery pack. It's got 5 times the volumetric energy density of Tesla's older 2170 format, which means engineers can hide power inside the robot's torso instead of strapping it to the back like a jetpack. That single change shaved 22 pounds off the robot, dropping its weight to about 138 pounds. Less weight means smaller motors, less heat, cheaper structural parts, and a ripple effect of efficiency gains. Back in 2022, when Tesla first showed off Optimus on AI Day, it could barely walk. Fast forward to May 2025, and Gen 3 is catching tennis balls mid-air, dancing in sync and threading needles, all in footage Tesla has shared. That leap forward comes down to a completely redesigned hand, a 22° of freedom gripper that doubles the articulation of Gen 2. It's now within 18% of the human hand's 27 mobile axes. Each finger uses a cable and tendon drive system, paired with touch sensors that can detect forces under 1 Newton. According to Tesla's benchmarks, that lifts the robot's pinch precision from 5 mm to just 1.44. In other words, it can now handle tiny, delicate tasks. In a clip from November 2024, the robot catches a glowing tennis ball flying at 40 km an hour, grabbing it in 380 milliseconds with no signs of remote control. By May 13, 2025, another video showed 2 Gen 3 bots dancing in unison for 47 seconds, keeping their hips, knees, and ankles within 1 degree of the programmed motion, a level of accuracy more common in motion capture puppets than free balancing robots. Independent robotics experts still point out that Boston Dynamics Atlas can do bigger jumps. But Optimus now owns the title for most articulated production hand in the game. And the software leap is just as big. Tesla ditched traditional joint space control in favor of a vision-first stack borrowed from its full self-driving program. Optimus now uses a trimmed-down version of the photon-to-control pipeline. It takes input from 8 global shutter cameras and runs that through a transformer-based neural network on Tesla's own FSD system-on-chip. That produces 100 Hz volumetric scene graphs, which feed into a predictive controller running at 500 Hz. The end result, the robot can respond from camera image to torque command in just 23 milliseconds, half the latency of Gen 2. Let us pause here for a quick reminder: if you're enjoying this deep dive, be sure to hit that subscribe button and help us reach our goal of 1,000 subscribers. Your support means everything to Auto Intel. Back to the tech, what's even more impressive is how the robot learns. On May 29, 2025, Tesla posted a video of Optimus folding t-shirts after just 45 minutes of watching first-person GoPro footage. That's a big shift from relying on remote-operated imitation learning. Tesla says the new video-only, self-supervised method cuts human teaching time by 70%. Gen 3 isn't just lighter. It's more capable, too. A teardown shared by Interesting Engineering puts the frame at 125 pounds, powered by 40 electromechanical actuators and a 2.3 kilowatt-hour structural battery built into the spine. That gives the robot enough juice for an 8-hour mixed task shift or 4.5 hours of non-stop walking at 5 miles per hour. At idle, it uses about 100 watts. At peak, while carrying 45 pounds, it draws around 500 watts. That translates into an energy cost of less than 2 joules per kilogram per meter, well within the range of adult humans. All that translates into real, measurable capability. Pinch force is up from 8 newtons to 24, enough to pick up a raw egg or tighten a 6 mm bolt to spec on the 4680 battery line. In over 1,000 repetitions of a 3-point pick-and-place task, position drift stayed under 0.6 mm, comparable to mid-range Scara arms that cost as much as the entire robot. Each limb now contains a 6-axis inertial measurement unit, feeding into a reflex system fast enough to recover from a 15 kg lateral shove. In one test, the robot regained its balance in 620 milliseconds, with just 4.3 degrees of ankle deflection. It's all built on a shared silicon base with Tesla's FSD chip, which means integrated sensing, actuation, and control. This whole-body compliance starts to blur the line between scripted robotics and biological movement. When you combine the upgraded hand, the sub-30 millisecond vision loop, and a full-shift battery, Gen 3 starts looking like more than a demo bot. It can stock shelves, reflow solder, assemble wiring, tasks that need real dexterity, not just walking. That could change everything. We're inching toward a point where these robots aren't novelties. They're labor solutions. And maybe even explorers. Elon Musk has gone on record predicting that Optimus will become Tesla's biggest product ever. Not just big, 10 times bigger than anything else the company has done. Think about that. When people hear humanoid robot, it still conjures up images of sci-fi fantasies or clumsy machines tripping over cables. It's easy to dismiss them. But the pace of change lately has been dramatic. We're not seeing slow progress anymore, we're watching a leap. It's not just Tesla and Boston Dynamics now. It's a global race, with companies in the US, China, and beyond pushing hard to make humanoid robots practical and affordable. Now, we're not here to declare Tesla the undisputed winner. But if we're talking about real-world usefulness, robots that might actually change daily life, then Optimus is the one to watch. Just last week on CNBC, Elon Musk doubled down on the number that's now the centerpiece of every conversation about Gen 3, under $20,000. He says that once Tesla's Fremont pilot line hits a steady clip of 1 million units a year, the full bill of materials plus overhead could drop to around $10,000. That would allow Tesla to sell the robot for less than the price of a used Corolla and still make healthy margins. For context, a basic 6-axis industrial arm costs around $45,000, and that's before adding grippers or tools. Boston Dynamics Atlas. Mid-6-figure leases. So Tesla's price point isn't just aggressive, it's disruptive. That disruption was felt immediately. When Tesla opened a no-commitment reservation form on May 17, it got 5,000 corporate sign-ups in the first 72 hours. GXO Logistics reserved 750 bots for third-shift palletizing. German grocer Ro booked 300 for restocking. A hospital in Thailand wants 120 for linen runs. These are very different industries, all seeing the same thing, at $20,000, the robot pays for itself in under 14 months, even before tax breaks. Tesla's own numbers are even stronger. A robot running 2 8-hour shifts at $18 an hour brings in $90,000 a year in value, while using about $2,000 in electricity. That's a 10-week payback. After that, it's pure return. And production isn't some future dream. As of January, Tesla said its first dedicated Optimus line was already building 1,000 bots a month. A second line, coming online in late 2025, will hit 10,000 units per month. In March, an internal meeting leaked where Musk challenged the team to finish 5,000 bots by New Year's Eve and stock parts for 10 legions in 2026. During the April earnings call, Musk said he's now comfortable forecasting 1 million units a year by 2029, 4 years earlier than planned. If that happens, Optimus could be the fastest growing hardware product in history. Faster than the Model 3. Almost iPhone fast. Even more interesting. Tesla will be its own best customer. Thousands of robots are earmarked for in-house use before any go to outsiders. Gigafactories will double as 24/7 showrooms. Each robot that spot welds a battery tray or hauls a tote becomes a walking demo for visiting execs. And yes, Tesla plans to lease them. $3,000 down, $2 per hour. That info was buried in a Wall Street analyst note after the Texas demo. It means even small companies can try these robots with little risk, paying only when they deliver results. Tesla is applying its full vertical integration strategy here. The same 48V powertrain from the updated Model 3, standardized actuators made on idle gigapress time, and FSD-powered inference on Dojo accelerators all come together to keep costs low. No other company can bundle compute, power, and hardware at this scale. That's why $20,000 doesn't just make Optimus competitive, it makes it a threat to the entire automation sector. Whether Tesla can hit the production targets is still an open question. But in terms of cost structure and demand, the math already works. If Gen 3 lands at that car-like price and delivers real labor, it could shift the very definition of work. For the first time ever, a robot could cost less than the yearly wage of the person it's meant to replace. And that brings us to Mars. The 2026 window has become the countdown clock for everything SpaceX is doing. And now Optimus Gen 3 is part of that plan. Speaking from Starbase on May 30th, Elon Musk confirmed that the first uncrewed Starship to Mars will launch in that window, and it will carry one or more Tesla-built humanoid robots. He gave it a 50-50 shot, but promised they'll try, even after a recent failed test. The Mars variant is cold-resistant to -20°C, has Kevlar-reinforced skin, and uses aerogel-lined carbon panels to keep electronics above 5°C without heaters. Its first jobs: roll out solar panels, trench cables, align Starlink dishes, and stack Lego-like bricks into 2-meter berms to block radiation and dust. Musk believes 30 robots, working 2 shifts, could build a 100-kilowatt station and a landing pad in 90 Martian days. So the big question, can a $20,000 robot survive better than astronauts? Drop your thoughts in the comments, we want to hear from you. And if you found this video insightful, do us a favor. Like, share, and make sure you subscribe to Auto Intel. We're on a mission to hit 1,000 subscribers, and with your help, we're almost there. Thanks for watching, and we'll see you in the next one. Take care.